स्टार्ट रिकॉर्डिंग स्टार्ट हो गई है, हो गया। हेलो, गुड इवनिंग। क्लियर, रिकॉर्डिंग ऑन है। ओके, वॉइस इज क्लियर? ओके। So in last class we were discussing about the Miller indices, right? So let's continue our discussion. So before before going to the means some mathematical aspect, let's understand once again what is Miller indices basically is all about. Okay, so let's see. Let's suppose there is some lattice points. Okay, let's suppose there is some lattice points. We all are aware about this lattice point, right? Okay. So I told you that Miller indices is what? It is basically shows us the orientation of a plane. Okay, it basically shows us the orientation of plane. See, I am saying if this is our lattice point, then there is an infinite number of planes are possible. Let's suppose this is one plane. I'm changing, wait, I'm changing the color here. This could be your one plane. Okay, this could be your second plane, basically passing from these two lattice point. Okay, passing from this two lattice point. Actually, yes, yes, it is. One second. Okay, so yes, what happened? सबका सही आ रहा है? It's clear. Okay. Okay, let's check it out, please. So what I'm telling you that in a lattice point, there's a crystal, infinite number of planes are possible. Okay, you can say, okay, this could be a plane. I am showing you. Wait. This could be your plane. This could be your another plane. Okay, basically lattice point will be on there. Okay, this could be your another plane. The infinite number of planes should be possible. Okay, let's wait. I am drawing this like that. Okay, so it will be easy for you guys to understand. Wait. Okay. I am denoting here some lattice points. Okay, so I am basically want to tell you that look at this plane. This could be your means set number 1. This could be your set number 1. These all planes are parallel to each other. Okay, these all planes are parallel to each other. Similarly, if you see, you can draw a plane like that also, like that. Okay, this could also be the plane. ये भी एक plane ही होगा, ऐसे भी एक set plane बन सकता है. Okay, so क्या, let's suppose हम इस set of plane को we just name this set of plane as HKL. Okay, HKL, and this is our some Miller indices, and just name this set of plane as H1, K1 and L1. See, there is a one method to define this plane, that okay, you can say this is set number 1, this is set number 2. But yesterday I also told you that if you have to define this set of planes mathematically, So how will you define? So for defining this set of planes, we need Miller indices, okay? We need a Miller indices. Miller indices will tell, okay, these all are parallel planes. So H1, K1, L1 or HKL should be our Miller indices, which will define, there were 3 coordinates which will define these set of planes. Okay, आप अगर देखोगे, अभी मैं आपको examples भी दूंगा, I will give you examples, you will see that the parallel planes have the same Miller indices. Okay, the parallel planes should have a same Miller indices, and the distance between these planes, if you talk about distance between these planes, this distance, this distance, this distance, these distance all will be equal. These all distance will be equal, okay, because there is a lattice point or in the square lattice or in the identical manner. So all these means you can say interplanar distance will be equal. So and this interplanar distance is defined by DHKL. We will derive the notation, we will derive the complete relation for that. So before going to the mathematical aspect, I want to tell you just one thing, that Miller indices is nothing but it represents the orientation of planes. Okay, it represents the orientation of planes. भाई बहुत इजी है ना कि आप इसको कह दो ठीक है सेट नंबर 1 है, कुछ ऐसा डिफाइन होगा तो सेट नंबर 2 होगा, बट सेट नंबर 1 सेट नंबर 2 हाउ विल यू गो इन द इनफाइनाइट लैटिस, कैसे आप डिफाइन करोगे? सो फॉर मींस आवर इजी पर्पस, हमें आसानी हो, फॉर दैट Miller gave us the concept of Miller indices. There is a set of 3 integer, okay, which will work so that we can see that, okay, this is 1 1 0, so this is our one plane, 0 1 0, this is our second plane. Okay, so basically in one line, Miller indices shows us the orientation of the planes in any lattice. Clear है सबको? आगे बढ़ें? Okay. Let's talk about some mathematical concept, that basically the main funda is how we will find the Miller indices. Okay, how we will find the Miller indices. So just give the topic name, that is Miller indices. Miller indices. Okay, it is visible? Yes. Miller indices. So what I told you, the first point I also discussed yesterday. First of all, choose the right hand coordinate system. It will be means it will constant for every type of means किसी भी plane का अगर आप Miller indices find out करोगे ना तो ये तो fix ही रहेगा. Right hand coordinate system. Right hand coordinate system. Okay. What was the second point? Just measure the intercept on their respective axis. Okay, just see the intercepts, or just find out the intercept on their respective axis. Intercept on respective axis. On the respective axis. Okay. Third one. When we will get the intercepts, and we always know that what is our lattice parameter, so for that I told you that the Miller indices will be defined as, Miller indices will be equal to or defined as the what? The ratio of lattice parameter and intercepts. Okay, lattice parameters and their intercepts. कई लोगों को कुछ थोड़ा confusion था that okay sir, अभी तक जो हम करते आ रहे हैं till this date we have done take a reciprocal or something or that. Okay, so just I want to tell you, just follow this. Okay, just follow this. Miller indices equals to lattice parameter divided by the intercept. You will get the means Miller indices of every plane. We will going to see the examples. Okay. Now, and what was our fourth step? Convert into the what? Least integer. Least integer. सबसे छोटे इंटीजर में कन्वर्ट करना है. Always remember, it can't be fraction. Fraction में नहीं रह सकता ये, ठीक है ना? You have to convert in the first of all integer, and then you have to make it the least integer. That will be your Miller indices. Understood? सही है यहाँ तक? Okay. So let's talk about some examples. Which is our main purpose. In exam, if there is any lattice is given, any plane is given, how will find the Miller indices of that lattice? Okay. So let's start. Sorry. Okay. So this is our cube. Okay. This is our cube. Is it visible for everyone? Yes. I want, okay. Just I want to know that what will be the Miller indices of this plane. Means this plane. What will be the Miller indices of this plane? Okay, now I am denoting this as you can take, this is your what? Y axis. This is your Z axis and this is your X axis. ठीक है ना? And let's suppose the side of the cube is A. Side is A. Side of the cube is A. And let's suppose this is our origin. First of all, tell me what will be the Miller indices of this plane. So for finding this, what the thing I told you, मैंने आपको क्या step बताया? First of all, just see about the, just go about the, first of all, go about the intercepts on their respective axis. So tell me, what will be the intercept on the x-axis? What will be the intercept on the x-axis? Intercept on x-axis. See, this plane doesn't intercept on the x-axis. ये plane x-axis को कहीं भी cut नहीं कर रहा. Intercept means what? Intercept means the cutting. जहां पर उस respective axis को वो plane cut कर रहा हो. So tell me, at what point this plane cutting the x-axis? This plane does not cut the x-axis, so we suppose that if this plane will cut the x-axis at infinity. अगर ये x-axis को नहीं cut कर रहा है, then we will take it as a this will cut x-axis to the infinity. ये infinity पे कहीं जाकर cut करेगा. Okay. Tell me, intercept on a y-axis. Intercept on y-axis. Y-axis पे कैसा intercept होगा? कहाँ पर cut कर रहा है y-axis को? At a distance a, okay. Now intercept on z-axis. Z-axis का intercept कहाँ पर है? Infinite again. Again, it does not cut the z-axis, so we will suppose that it will cut the z-axis at the infinity. So the intercept will be infinity, right? So these three are our intercepts. Okay, and we know about the lattice parameter. What are the lattice parameters? For the cube, it is A equal B equal to C, that is, let's suppose A. Okay, lattice parameters भी हमें पता है. Just find out the Miller indices. Let's see. What I told you, simple, what I told you. Lattice parameters divided by the intercept. Just do this. What is the lattice parameters? A, B, C are equal. Okay, so you can define this like as H, K, L, H is to K is to L, and that will be equals to lattice parameter, that is A, and intercept. On x-axis, how much? Infinity. Similarly, for the y-axis, intercept is also A, and sorry, lattice parameter is also A, and intercept at A. Now, for the z-axis, lattice parameter is A, and intercept at infinity. ठीक है ना? बस हो गया. ये होगा आपका मिलर इंडिसेस. 1 by infinity is how much? 0, 1, 0. So you can write H, K, L without comma at 0, 1, 0. This is our Miller indices. What was the fourth step? To convert into the least integer. It is already in the least integer. It is already in the least integer, so you can't change it anymore. So this is finally the what? Miller indices. देखा आपने? कहीं कुछ रेसिप्रोकल करना पड़ा, कहीं कुछ एलसीएम वगैरह कुछ लेना पड़ा. ओके, आप कहोगे ओके सर इसमें दो दो जीरो ही हो रहे थे, ठीक है, नंबर्स वाला भी देखते हैं. Okay, just remember these things. I told you, Miller indices is equals to lattice parameter divided by their respective intercept. That's it. That's the basic simple equation of the Miller indices. आप इसको डिवाइड कर दोगे, बाकी सब तो आप मैथमेटिक्स खुद ही कर सकते हो ना. Okay? See, yes. I am telling you. See, this plane. Just visualize this plane. I am telling you. I am asking you that at what point. At what point this plane cutting the z axis? किस पॉइंट पर ये प्लेन z axis को कट कर रहा है? कहां कट कर रहा है, आप बताओ. नहीं कट कर रहा है. So in the concept we suppose that it will cut at the infinity. जब कहीं नहीं कट कर रहा है, so we will take it will cut at the infinity. Why? It's just like a simple thing that the two parallel line cuts where? That's the same concept we are applying here. Okay, and that this is similar for the x-axis also. X-axis पे cut नहीं कर रहा है, so we will suppose that it will cut the x-axis at the infinity. That's why we have taken the intercept on the x and z-axis at the infinity, and it is cutting the y-axis at the distance a, so the intercept will be a. Clear? Okay, now I'm going to show you the concept of parallel planes. Wait. Yes. Now, see. Let's take whether some different colors. Okay. I am making this plane. I am making this plane. इस प्लेन की अगर हम बात करें, विजुअल है ना, रुको मैं फिर से कर देता हूं. Simply take the, okay, just see this plane. Now, tell me, let's suppose this cuts the y-axis at the half of the least lattice parameter. Let's suppose it's cut on the x-axis at the a/2. Now tell me. Okay. Now tell me. What will be the first of all intercept will be same, remain same. What will be the intercept on the x-axis? Intercept on x-axis. Infinite. भाई कुछ चेंज थोड़ी ना हुआ है वहां से. Okay. Again, it will cut at the x-axis at the infinity, right? Now, intercept on y-axis. What will the intercept on y-axis? a/2. Okay, a/2. Okay, I have written here a/2. What are the intercept on z-axis? Also infinity. ठीक है ना, infinity पर ही होगा. Now, अरे सर z एक्सिस को कहां कट कर रहा है ये? हमने क्या किया है? Just see what we have done. We have just shift the distance over the y. इस प्लेन को हमने शिफ्ट करके यहां कर दिया है और थोड़ी ना कुछ हुआ है. z एक्सिस और x एक्सिस में थोड़ी ना कुछ फर्क पड़ा है. It does not affect the x and z axis. कहां? Where it is cutting the z axis? Tell me. कहां कट कर रहा है z एक्सिस को? It is cutting in the infinity, and similarly, where it is cutting to the x-axis? At the infinity. Clear hai? Don't get confused. Okay. Now, so okay, we have got the intercept. We know the means lattice parameter. Let's find out the Miller indices. What will the Miller indices? H is to K is to L. That is lattice parameter. That is A divided by the infinity is to A divided by A by 2 and is to A divided by the infinity. Clear hai? Okay, so what will be the Miller indices here? Miller indices कितना हो जाएगा? 0 to 0. 0 to 0. But I told you na, just convert it into the least integer. Divide all 3 by 2. तीनों को 2 से divide कर दो. So it will be 0, 1, 0. Are you getting the same Miller indices which you got for this plane? Clear hai na? Okay. So means for this plane and for this plane we are getting the same Miller indices. Okay, let's do one more. I want to tell you one more important concept. That's why I'm doing these examples. Now, yes, let's take another, let's say black. What will be the Miller indices of this plane? It will not be visible actually. Let's see. What will be the Miller indices of this plane? इस plane का Miller indices क्या होगा? Can anyone find out? Please. Zero, 1 bar 0. How? See, everyone, every guys, please pay attention here. I want to tell you one more basic concept for the Miller indices. That's why I have drawn this plane. See, what is the means where the plane cutting on the x-axis? Here infinity, on the z-axis also infinity. But see, hang on. The main concept of Miller indices is that you can't take origin including the planes. आप मेरी बात को ध्यान से समझिएगा. I want to tell you that you can't take origin. You can't take origin on the plane. Means your plane should not cut the origin. यहाँ पर क्या हो रहा है इस प्लेन का देखना. ये origin से पास होके जा रहा है ना. इस प्लेन में ऐसा नहीं था ना. This plane was separate. This plane was also separate. But see this plane. This plane cutting this origin here. Okay. Understood? आवाज आ रही है? सबको clear है? This plane is cutting this origin here. So for this type of concept, इस तरह के planes के लिए हम इसका Miller indices कैसे निकालेंगे? How will we find the Miller indices for this type of planes? We have to shift the origin. Okay? We have to shift the origin. Note करके आप अपनी notebook में लिख लीजिए. Please write down on your notebook while heading notes that origin must not include the plane. Okay, means plane should not passing through the origin. Origin से plane pass नहीं होना चाहिए. If it is so, अगर ऐसा है, then you have to shift the origin. Then you have to shift. I am saying that your plane for which you are finding the Miller indices should not passing through the origin. उसके रास्ते में origin नहीं आना चाहिए. Should not pass through the origin. If it is so, like in this plane, if it is so, then we have to shift the origin. हमको origin को क्या करना पड़ेगा? Shift करना पड़ेगा. See how. I am making another cube here. Just for this plane. Okay? Now. See, y-axis will remain y-axis as it is. Here it was origin, na? Origin यहाँ पर था ना? I have taken the origin now here. Here I have taken the origin. Let's suppose I have shifted the origin here. So this will be our z-axis and this will be our x-axis. Clear hai? We have nothing. We have do nothing. We have just shift the origin. Why? because the plane for which we are finding the Miller indices was passing from the origin. Origin को touch करते या cut करते हुए जा रहा था. Okay, that's why. Now, let's find out the Miller indices of this plane. अब बताओ. Now it is easy for you guys, na? Now tell me, what will the Miller indices? First of all, find the intercept. What will be the intercept on the x-axis? First of all, tell me intercept on x-axis. Intercept on x कितना होगा? Infinity, obviously infinity. Don't look now. Now don't look the origin here. आपका origin shift हो चुका है. Your origin has been shifted. Now you have to just see this. आपको अब इसको focus करना है. इस plane के लिए इसको focus करना है. You have to focus on this origin. Okay. Now tell me, where this plane cutting the x-axis? Infinity. Okay. Very good. Where this plane cutting the y-axis? Minus a. Minus a. This time, this y-axis has been cut by the intercept at a distance minus a. So the intercept on y-axis is equals to minus a. And intercept on the z-axis? Again infinity. Good. Intercept on z-axis will be infinity. Okay. जल्दी से Miller indices बताओ. Tell me the Miller indices of this plane. Yes, exactly. It is quite easy, na? See. HKL. Yes, you both are right. I'm telling you. Wait. Lattice parameter divided by the intercept. That is a upon infinity, a upon minus a upon infinity. So the Miller indices will be how much? कितना हो जाएगा Miller indices? It will be 0, -1, but here we don't use the minus sign, we use the bar sign. 1 bar 0. Okay? Where you get the bar, आप समझ जाओगे, it is represent the minus. So this will be your Miller indices. This will be your Miller indices. Tell me, if you divide all the three integers by -1, what will you get? Divide all three integers by -1. 0, 1, 0. भाई 0, 1, 0 मिलेगा ना? That the Miller indices will be 0, 1, 0. क्या मिला आपको? इस प्लेन का Miller indices कितना मिला? 0, 1, 0. Okay. So basically, all the three planes are having same Miller indices. Let's suppose this is plane number 1, this is plane number 2, and this is plane number 3. ठीक है ना? All three planes have same Miller indices, and the MI is what? 0, 1, 0. So this is called a parallel planes. इनको हम क्या बोलते हैं? They are the parallel planes. बात समझ में आ रही है? Understood? See, we have seen now this plane, and this plane. All three planes have same Miller indices. All three planes have the same Miller indices, right? So we can say this as a means parallel. You can say this as a parallel planes. Okay, this will be a parallel planes. इसको भी मैं हटा देता हूँ ना, इसकी जरूरत नहीं है. Wait. Okay. Okay. Hence, since I'm writing down here, since plane 1, 2, and 3 all have, write down on your copy also, all have same Miller indices, that is how much? 0, 1, 0. Hence these are called as what? Parallel planes. These are called the parallel planes. और एक चीज और बोलेंगे, वी ऑल्सो सेड दैट ऑल दीज थ्री प्लेन्स आर फ्रॉम अ वन फैमिली, ये तीनों एक सिंगल फैमिली के होंगे. ओके, ऑल दीज थ्री प्लेन्स विल बी फ्रॉम अ सिंगल फैमिली बिकॉज इट रिप्रेजेंट्स द सिमिलर इंडिसेस. राइट, यहां तो सबको क्लियर है, एवरीवन इज क्लियर. किसी को डाउट हो पूछ सकते हो. इफ एवरीवन हैविंग एनी डाउट कैन आस्क. यस. हाँ, ओके. हाँ बिल्कुल रहेगी. आप एक इनफाइनाइट एक्सिस, आप इनफाइनाइट लैटिस बना, यू मेड इनफाइनाइट एक्सिस. ओके, जस्ट ड्रॉ द इनफाइनाइट एक्सिस, मींस 2 और 3 क्यूब, जस्ट जॉइन द 2 और 3 क्यूब्स. आप उसमें देखना सारे प्लेन, जैसे कि एक प्लेन यहाँ आया, अनदर प्लेन हियर, अनदर प्लेन हियर, अनदर प्लेन विल बी हियर, अनदर प्लेन विल बी हियर, ऑल विल हैव द सिमिलर इंडिसेस. ओके, ऑल विल हैव द सिमिलर इनफाइनाइट लैटिस. चलते चले जाओ आगे पीछे, ऑल द जितने भी पैरेलल प्लेन्स बनेंगे, ऑल द पैरेलल प्लेन्स विल बी फॉर्म हियर, ऑल शुड हैव द सिमिलर इंडिसेस. राइट, clear? Now from here one more concept generates. What? Oh shit. Okay, from here one more concept generates. See, tell me what will be the distance between these two planes. What will be the distance between these two planes? No. Wait. These two planes, the distance between these two planes will be represented by DHKL. Okay, DHKL. It will be represented by DHKL and it is called the interplanar spacing. DHKL, it is called the interplanar distance, interplanar distance और spacing. हम इसको डिस्कस करेंगे when we will complete the Miller indices. We will discuss this thoroughly. We will derive the relation for the interplanar distance. But here I have introduced the name here because just to let you all guys that what is the interplanar spacing actually is. ठीक है ना? Basically interplanar spacing क्या बता रहा है? Basically tell us the distance between the two planes, two parallel planes. All the planes have same Miller indices. All the planes have same Miller indices. So what will be the distance between these two planes? Obviously, the distance between these two planes and these two planes will be equal. भाई जो distance इस plane का होगा वही distance इस plane का होगा, इन दोनों plane के बीच का होगा. Right? So the both the difference. Or if you extend the lattice on the infinite extension, all the distance between two consecutive planes will be equal. समझ में आ रही बात? Understood? All the distance between two consecutive parallel planes will be equal, and that will be represented by the small d HK. I am telling you a formula here. We will derive this. The formula is d is equals to 1 over under root h square by a square plus k square by b square plus l square by c square. This is the basically relation. Okay, I have just introduced here because we have studied the concept of parallel planes, so that when we will introduce tomorrow this concept, you will guys easily get to know that what is the interplanar spacing. Okay, किसी को problem है what is the interplanar spacing here? Basically this is the distance between the two parallel consecutive planes. Right? Clear है सबको? जो भी हो आप रख दो. HKL इज गिवन ना, HKL तो हमें पता है 0 1 0. हमें भाई क्यूबिक लैटिस है तो हमें लैटिस पैरामीटर आल्सो नोन. जो भी आएगा कितना आएगा? ए ही आएगा, ए डिस्टेंस. ओके, हाँ see, this is a general relation. This is the general relation. Okay, we will derive the complete derivation. Don't worry about this. I have just mentioned here to let you guys know that the distance between these two planes are the interplanar spacing called. जो भी आएगा देख लेंगे. इसके ऊपर हम separate practice भी करेंगे questions की. Don't worry. Okay, for why I have introduced in today's class? Because I have introduced the concept of parallel planes. Okay, so you guys will easily get to know that okay, what is the small d actually here? It is the interplanar spacing. By नाम से ही clear है. It is clear from the name itself. Interplanar spacing means the distance or space between the two planes. This is the two planes. इनका distance by equal होगा. Okay, all the distance between two consecutive planes will be equal. Right? Clear है? आगे बढ़े? Okay. Now let's do some practice on different planes. Okay, so that you guys get habitual for this. Now okay, let's suppose this is y, this is x, this is z, and this is our origin. Let's suppose it cuts, this is the distance a, this is the distance a, and this is also a distance a. Quickly tell me the Miller indices for this plane. Everyone please solve. 1 1 1. Okay, see, we have nothing to do, just simple see the two things. First is lattice parameters. Okay, we have already said that distance, let's suppose the lattice parameter is a here. Okay, the lattice parameter divided by the intercept. So the intercept here is a, divide both, you will get a 1 1 1. Okay, let's solve some more problems. Okay, let's solve some more problems. आप इसकी अच्छे से प्रैक्टिस कर लोगे ना? If you guys do the practice for, yes, it will be 1 1 1 1 1 1 ही होगा, don't worry. Okay, I won't write the axis again and again because it is quite understable that it will be the right hand coordinate system. Okay, so if the axis is not mentioned in the question, never get bothered about that. Okay, this is your z axis. So means you have to find okay. Now tell me the Miller indices of this plane. Let's suppose the side of the cube is A. Let's suppose the side of the cube is A. What will be the Miller indices of this plane? What? 0 1 1. Okay, it will be 0 1 1. What is the intercept on x-axis? Intercept x-axis पे कितना है? कहाँ पर कट कर रहा है? Where this plane cutting the x-axis? Infinity. Infinity. So the intercept on x-axis is infinity. Where the plane cutting the y-axis? E. Okay. Where the cutting the z-axis? Also A. Okay. Just simply divide. So the MI, that is Miller indices, that will be HKL, and it will be equals to how much? 0 1 1. Okay, it will be 0 1 1. ठीक है, क्लियर हो रहा है, समझ में आ रहा है ना कैसे कर रहे हैं हम ये? ओके ओके, जस्ट आई एम गिविंग यू वन मोर क्वेश्चन. आई विल गिव यू सम होमवर्क ऑल्सो, आई विल सेंड यू ऑन अ ग्रुप. ठीक है ना, आप उसको सॉल्व करना. ओके, आई एम नॉट मेकिंग अ कोऑर्डिनेट अगेन हियर. ओके, इट इज क्वाइट अंडरस्टूड दैट इट विल बी द राइट हैंड कोऑर्डिनेट सिस्टम. ठीक है ना, कंफ्यूज मत होना आप लोग. ओके, just find out the Miller indices of this plane. of this plane. What will be the Miller indices of this plane? बताओ, what will be the Miller indices of this plane? Let's suppose take the origin here. Let's do मतलब सभी को करने दो. Let's everyone do. 1 बार किस पर आ रहा है आपका? X एक्सिस पर. Please find everyone. We have taken this as a origin, this point as a origin. Find out the Miller indices of this plane. Zero, one, one. No. Zero, zero, zero. भाई 0, 0, 0 का मतलब है प्लेन ही नहीं है. प्लेन तो दिख रहा है मुझे यहाँ पे. See, first of all, हाँ 1, 1 bar 0. No. See, सबसे पहले तो मुझे आप ये बताओ, फर्स्ट ऑफ ऑल टेल मी, बिना ओरिजिन शिफ्ट के क्या हम इसको सॉल्व कर सकते हैं? सबसे पहली बात तो यही है. यस, इट इज अ 1, 1 bar 0. Yes. See how? Huh? Anyone got the answer? 1, 1 bar 0? Okay. See. Again, just draw the cube here. So it will be quite easy for you guys. ठीक है? Now, what we have done, we have shift the origin. हमने origin को shift कर दिया. Let's put the origin here now. Here it is the origin here, okay? Origin हमने यहाँ पर ले लिया. So just tell me, this axis will be the y-axis, okay? This axis will be the y-axis. इसमें किसी को प्रॉब्लम है? ये तो as it is रहेगा ना. This will be the y-axis. X axis will be this one. ये x axis बन जाएगा. ये हमारा z axis बन जाएगा. This will be our z axis. Okay. Now this will be our origin. Right? Where is the plane? Plane is here. Now, भाई आप बताओ मुझे, जस्ट टेल मी वेयर दिस इज कटिंग ऑन एक्स एक्सिस. एक्स एक्सिस पे कहां पर कट कर रहा है ये? हाँ, इट इज कटिंग ऑन द ए. इट इज कटिंग ऑन द ए. जस्ट सी ना, दिस इज आवर एक्स एक्सिस एंड दिस इज अ डिस्टेंस ए. हियर इट इज कटिंग ना, यहां पर कट कर रहा है ना एक्स एक्सिस को. सो द इंटरसेप्ट ऑन एक्स एक्सिस विल बी हाउ मच? आई एम राइटिंग डाउन हियर. इंटरसेप्ट ऑन एक्स एक्सिस कितना हो जाएगा? ए. ओके. व्हाट इज द इंटरसेप्ट ऑन वाई एक्सिस? माइनस ए. वाई एक्सिस को कहां पर कट कर रहा है भाई? अगर ये हमारा ओरिजिन हो गया, इफ इट इज आवर ओरिजिन, देन दिस विल बी आवर फॉरवर्ड एक्स डायरेक्शन, दिस विल बी दिस विल बी आवर फॉरवर्ड वाई डायरेक्शन, दिस विल बी आवर नेगेटिव वाई डायरेक्शन. सो इट विल कट द वाई एक्सिस ऑन द माइनस ए. सो द intercept on y at minus a. Where it is cutting the z? Infinite. Z को कहाँ कट कर रहा है? Z देखो, see the z axis. Z axis is here, plane is here. आप एक्सटेंड करते चले जाओ, कहाँ कट करेगा? Where it will cut? It will cut at the infinity. So the intercept on z axis will be infinity. ओके. सो मिलर इंडिसेस कितना हो गया? h is to k is to l. It will be how much? a by minus a and a by infinity. So the Miller indices will be 1, 1 bar 0. क्लियर है? Yes. No, these two are not same. Okay. Yeah, right. You are right. You are right. 1 bar 0 will also be same, because if when you will divide the -1, it will you will get the 1 bar 0. Yes, you are right, because that plane 1 bar 1 0 will also represent the plane of the same family. Okay, and when you will draw the 1 bar 1 0, that plane which should be parallel to this plane. Yes, you are right. You are right. Okay, 1 bar 1 0 should be also the Miller indices. Okay, आप -1 से divide कर दो तीनों को. You can do. Clear है? Okay. So I'm sending you some questions on your group, because class time is over. Your electronics class is around. See, lot of question can't be solved in the class due to the time constraint, but it can be solved you by the homework. So I'm sending you on your WhatsApp group. Please solve everyone on each of the question and send me back, okay? So that tomorrow onwards I can extend our topic to the interplanar spacing. Please solve the homework for everyone, क्योंकि कुछ ही लोग मुझे वापस भेजते हो, ठीक है ना, बाकी सब लोग का होमवर्क नहीं आता है मेरे पास. Okay, so please do the homework in, not in the solid state physics, in every subject. Okay, understood? Within a 1 hour or 2 hour I will send you on a WhatsApp group. Okay, clear? Okay. Yes, for this. Okay, I will send. Why you didn't make the notes? Why you didn't make the notes? ऐसे क्यों कर रहे हो भाई? आप जब खुद से लिखोगे, इट विल, मैं पीपीटी में शेयर कर दूंगा, उसमें क्या है, पीपीटी शेयर करने में कोई बहुत बड़ी बात थोड़ी ना. आई विल शेयर, बट आप उसको खुद से लिखा करो ना क्लास के ड्यूरेशन में. ओके ओके, सो यस. हाँ, means 1 bar 0 and 1 bar 1 0. Yes, it will be because see, when you will see the plane 1 bar 1 0 na, 1 bar 1 0 plane, that plane should be the parallel to this plane. आप देखना वो इसके parallel ही आएगा. Exactly, all the parallel planes should be inclined the same family. Okay, और उन्हीं के बीच के डिस्टेंस को हम क्या बोलते हैं? That distance called the interplanar distance or interplanar spacing. Okay, see you guys. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.